What if you could know the future? Not the future, but the future of a different choice. It feels like medicine or economics. That's kind of the holy grail, right? Answering that one simple question, what if? Well, today we're diving into something called CausalFM. It's a brand new AI framework that promises to do exactly that. And, it might just change the game completely. Okay, so let's make this real. Imagine you're at the doctor's office. They have two different treatments for what's ailing you. So, which one is the best one? For you. Not for the average person, but for your specific body, your unique health profile. That's a huge question.
And to get the answer, you'd basically need to see into two different futures, right? You'd need to see the world where you took drug A and the world where you took drug B. That's the core of this whole what-if problem. We've got to know the outcome before we make the choice.
So this whole what-if challenge, it's not just some thought experiment. It's a real field of science. And getting it right, that's the absolute key to making good decisions in pretty much every field you could imagine. It's called causal inference. And here's the most important part. It's all about getting past simple correlation. Just because two things happen at the same time doesn't mean one causes the other. We need to know for sure that A causes B. That's the only way you can build a foundation for a decision you can actually trust. So if causal inference is so incredibly important, what's been the holdup? Well, for years, the way we've tried to use machine learning to do it has been, incredibly inefficient. Here's the big bottleneck. The old way was just painful. For every single new what-if question, every new data set, you had to build and train a completely new model from scratch. The dream, the goal, has always been to have just one single powerful model that can handle any causal question you throw at it. And this process has been a total drag on research. Think about it. You get new data, you have to pick the right kind of model, train it from scratch, which can take hours, sometimes days, validate it, and then, for the very next problem, you have to do the entire thing all over again. It's just a massive time sink.
But what if there was a way to break out of that loop? This is where a really powerful idea from the rest of the AI world starts to come into play: foundation models.
And you're already familiar with these, even if you don't use the name. Think about large language models, the ones that power things like ChatGPT. They're not retrained every single time you ask something new, are they? No way. They get trained once on a ton of data, and then they can just adapt instantly to almost anything you ask. That is the magic of a foundation model. So that leads to the million-dollar question, doesn't it? Can we take that same train once, use anywhere logic and apply it to the science of cause and effect? Can we actually build a foundation model that answers these what-if questions instantly?
Well, this is exactly what the CausalFM paper is all about. And their answer is a big, resounding yes. So let's break down how they actually managed to pull it off.
First things first, CausalFM isn't just one single model. It's more like a recipe, a framework for building these models. And here's the really clever twist. It doesn't learn from messy, real-world data at first. Instead, it gets pre-trained on millions of synthetic, simulated causal worlds. It's like it goes to a virtual school to learn the pure physics of cause and effect from the ground. So what's under the hood? Well, there are a few key ingredients. First, these things called prior data fitted networks, or PFNs. Just think of them as a special AI engine that's really good at learning on the fly. Then you have structural causal models, or SEMs, which are basically the blueprints used to generate all that synthetic training data. And the result of all this is something called in-context learning. And that's the magic trick. It's the ability to look at a brand new data set and make a prediction right then and there. No retraining needed. But the real secret sauce, the thing that makes this whole system work, is a concept called identifiability. Okay, think of it this way. The true causal answer you're looking for is locked inside your data. It's in a box. Most AI just tries to guess the combination. CausalFM is different. It requires you, the researcher, to provide the key, which is your scientific assumption about how the world works. This is so important because it means the model isn't just finding correlations. It's using your key to properly unlock the actual cause and effect relationship. And what's so powerful about this framework is that you can train it to handle all different kinds of locks. You might have a backdoor problem where you need to adjust for other factors, or maybe a front door problem with a mediator variable, or even an instrumental variable situation when there are hidden confounders. CausalFM can learn to handle all of them as long as you tell it which key to use for which lock. Okay, so the theory sounds amazing, right? But the big question is, does it actually work in practice? Well, let's take a look at the results. First up, accuracy.
And for this chart, just remember, lower is better. And look at that. CausalFM is right down there, performing just as well as, and sometimes even better than, those old-school specialized models that took forever to train for just one job. So yeah, it's not just flexible, it's also really, really accurate.
But honestly, here's the real showstopper, the speed. Because it does everything in context and skips that whole retraining step, it's not just a little faster. We're talking about being around 40 times faster. A process that used to take you minutes, maybe even hours, now happens pretty much instantly.
And this right here, this shows why that whole key concept is so critical. The researchers ran an experiment. When they gave the model the correct key for the lock, the error was super low. Great. But then they tried giving it the wrong key on purpose. And look, the error shot way up. This proves the model isn't just winging it. It's rigorously applying the structure you give it, which is exactly what you want.
You know, the authors of the paper put it perfectly. They said this is, quote, a novel paradigm with the potential to fundamentally change how practitioners perform causal inference in medicine, economics, and other disciplines. I mean, that's not just a small improvement. That's a fundamental shift.
So, let's zoom out. What does all this actually mean? Could we be looking at a whole new era for how we do research and make decisions?
So, why does this matter? Well, for one, it could accelerate science like crazy. Researchers can test out their ideas almost instantly. It means we can make better, more reliable decisions, whether that's in business or for public policy. It also helps democratize this stuff, putting these powerful tools into more people's hands. And this last one is huge. It doesn't just spit out an answer, it tells you how confident it is. And for any big decision, that's absolutely critical.
And that brings us to one last thought to leave you with. For so long, the biggest problem has been just getting the answer to our what-if questions. That was the bottleneck. But now, that bottleneck is starting to vanish. So the challenge is shifting. It's no longer about how we get the answers. It's about figuring out what are the most important questions we should be asking in the first place.